Jai Hind. Myself, Dr. Amita Asthana from Ajay Kumar Garg Engineering College, Ghaziabad. So, in this video lecture, we will solve a few important questions for your university examination, and the subject is Fundamentals of Electronics Engineering, subject code PC101. So, here are the questions we will discuss. The first question is, explain the characteristics of tunnel diode. It's an important question, and this question can come in your examination, right? So this is a 2-mark question. So you have to write all the importance. See, tunnel diode is a large topic, okay, but you have to answer it in only 2 parts. So you will cover only most important points regarding the tunnel diode. So how would we write the answer of this particular questions? They are saying explain the characteristics curve. Understand the question. They are asking the characteristic curve of the tunnel diode. So we will certainly make the characteristic curve. If we are not making the characteristic curve and just explaining, the examiner is not going to give you any mark for the question. So these are the common mistake. We are not supposed to write so much about the tunnel diode. He is asking only the explain the characteristics of tunnel diode. So at once we will make the characteristics of the tunnel diode and mark the important points and the regions on the characteristic curve, right? So here we will draw the VI characteristics of tunnel diode. On the y-axis, this is current, and on the x-axis, this is a voltage versus current curve. The tunnel diode, as we increase the voltage, the current is increasing. Reaching at the peak point, the current starts decreasing, and then at the valley point of this, the current again starts increasing. So here, this region where the current is decreasing as we are increasing the voltage, this is known as the negative resistance region. This region of the tunnel diode is very important for so many electronics application. So basically the examiner wants you to explain this particular region. Now you will mention all the points. VP as peak point voltage, VV is valley point voltage, IP is peak point current, IV is valley point current, right? Now I have just, if you remember, then you can just draw the symbol of the tunnel diode as to make the examiner to be sure that you are coming for examination with good knowledge, right? So the tunnel diode is a PN junction diode that exhibits negative resistance region that already have shown between two values of forward voltage, that means between peak point voltage VP and voltage valley, that is VV, right? Tunnel diode is basically a PN junction diode which has heavy doping. See, all the important points have been covered in a 2-mark question. You have made the characteristics, you are explaining that it is having heavy doping, you are showing the negative resistance region in the graph and explaining that is occurring between the valley point, the peak point and the valley point. This is better way to answer the question. Answer according to the question. That's it. Few more points we have write that the same, that heavy doping at very low voltage, tunneling effect causes many valence electron to move from valence energy band to conduction band. Some tunneling, some 1-2 lines for tunneling phenomena we can also write, so that examiner doesn't think of cutting any mark. But from point P to V, forward voltage increases but current decreases. This region is known as negative resistance region. Now the answer is complete for 2 mark, right? Coming to the next question, again the same question is here. They are asking how FET can be used as voltage variable resistor. So they are again asking the question and you have to answer only according to the VVR, right? A field effect transistor work as voltage variable resistor in the ohmic region. Again, you have to mention where it is working as VVR, in the ohmic region. FET works as amplifier in saturation region, clearly mentioned. And FET is a device that is usually operated if the constant current region on its output characteristics. Okay. But if it is operated on the region prior to the pinch off where VDS is small, below 100 millivolt, it will behave as voltage variable resistor. It is because the fact that drain to source resistance RDS can be controlled by varying the bias voltage VGS. Okay. So here this is the way to answer this question. Okay. Sorry. That the FET is working as VVR in ohmic region and it is working as amplifier in the saturation region. If you want, see, you can also make the curve and show this ohmic region. Like this is the current I and this is the voltage. So at some VGS, okay, these are the pinch off voltages. Now this particular region is known as the ohmic region. Here in this region the FET is working as VVR, and you can also mention that this region is the saturation region. Okay, so you can complete your answer by making the output characteristics of FET. Now the next question is convert the octadecimal number in hexadecimal, right? Okay, and this is for 1 mark, and again he is asking convert this binary to decimal, again 1 mark question. You have to answer both for 1 mark. Now from converting octal decimal number to hexadecimal, we have to take the help of decimal number. So we will convert first of all this octal number into decimal number. So 4 into 8 की power 0 plus 3 into 8 की power 1 plus 5 into 8 की power 2, that will give you the decimal number 348. Now you have to convert the decimal number by the this division method, that you will divide, this will go 21 times, the remainder is 12, and then 16, this will go 1 time, the remainder is 5, and then this is 1. Now the answer is 15C in hexadecimal. So you will show the steps involved. Not you have to use the direct your electronic calculator, but you will show all the steps to solve the question. Okay. Now one part is again there, that is convert this binary number into decimal number. Okay. So here this is 0, 1, 2, 3, minus 1, minus 2, minus 3. These are the weights in 2 की power, and then 1 into 2 की power 3, 1 into 2 is raised to power 0, 0 into 2 power 1, 1 into 2 power 2, 1 into 2 power 3, plus like this you have to 0 into 2 power minus 1, 1 into 2 power minus 2, and 1 into 2 power minus 3. Sum all these and you will get the final answer in decimal number, right? Now coming to the next question, they are saying evaluate using 2's complement. They have given two binary numbers. Now what we are doing is they are asking that use 2's complement method. You don't have to do the directly subtraction from your calculator. See, the examiner is certainly going to see your the way of attempting the numerical or solving this particular question. So you have to show step by step in a very clear manner, right? In 2's complement, what we do is whenever we are answering the question, we will first of all see which number out of which which method we are using. We are subtracting smaller number to greater number or greater number minus smaller number. So we will just find out the case first. This is the case where we are subtracting a larger number from a smaller number, right? So first number is this one and second number is this one. Okay, so we will take the 2's complement of the larger number. The method is take 2's complement of the larger number, like 1 0. We have to do this. Now we will take these 2's complement of this number. So we have just inverted the inversion of the bits, that we have 1 0 1 0 1 0 0 1, converting 1 to 0 1 to 0 and then adding of 1. So this is my 2's complement of the second number, right? Now what we will do, we will add these two numbers, the 2's complement of the second number and the first number. Now we have added these two numbers. Now we have added this number to this number. Okay, this number we are adding to the first number. Now we have done the addition part. Now whatever is the answer, put it in a bracket, take 2's complement of the answer and put a minus sign here, because we know that we are subtracting larger number from a smaller number, so we are going to get a negative sign also. So 2's complement of the result we will take and we will put a minus sign here. This is the answer. We will take 2's complement of this number and this would be the final answer to the question. Okay. So in this way you have to show all the steps, right? If you are not showing the steps but you are writing directly, then you are not going to get any mark in the university exams. So be very, very careful whenever you are answering any question. Be very, very careful about answering the question. Okay. Now, a 7-mark question we will do now. And this question we will first of all understand and then we will solve this question, right? Now coming. So, determine and sketch VO for the network shown in the figure. Okay, read carefully the question. Don't be in so much of hurry. Now, this is the input waveform. A sinusoidal input waveform has been given for the question. Now, see this. The capacitor is here and the diode is ideal and here it is being biased by the 20 volt. Okay. See this 20 volt and this peak is 120 volt, right? Okay. You have to sketch the waveform across this resistance. Now we have understood that this is a clamper circuit question because it is involving one capacitor over here, right? Now we will solve this question. See, the diode is forward bias due to the positive half cycle of the input waveform, right? This diode is ideal. This is being forward biased due to this input waveform forward half cycle. But you can see that this 20-volt battery is reversing it. Okay, this 20-volt battery is reversing because this N side is connected to the positive terminal of the battery. So when the input waveform will go beyond 20 in the positive side, then only this diode will be forward bias. Okay, right? And in the clamper case, we start the numerical at that point when the diode gets forward bias, because we have to charge this capacitor here and we will calculate the VC voltage across the capacitor. So we will see the diode when it is forward bias. Okay, so we will make our case 1 and remake the circuit accordingly, right? When the input voltage is greater than or equal to 20. Okay, the diode okay, we will remake the circuit. And in forward bias, the diode will become a short circuit. Okay, now this VO is the voltage across these 2 points, and when the input voltage is beyond 20, the voltage across this resistance R is nothing but 20 volts. Okay, right? This voltage across these 2 points is 20 volt. So the voltage here, this resistance is parallel to the battery. So voltage here will be the 20 volt. Now this output voltage when Vi is greater than 20 volt, case 1. Now I want to find out the charge on this capacitor Vc when the Vi is at its peak. That means when the Vi is 120 volt, then I will find out the capacity this. So I will apply KCL in this loop. Plus Vi minus Vc minus 20 is equal to 0 in this loop. So Vc is equal to Vi minus 20. When Vi is equal to 120 volt here, when Vi is equal to 120 volt at this point, then Vc is equal to 100 volts, right? So at the peak voltage we have found out the maximum capacitor charging. This result we will keep with us. Now we will go to that cycle where the capacitor is getting reversed bias. Case 2. And at that time the capacitor has been charged like this and the diode is reverse bias, it is open. For every case we will definitely check that the diode is reverse biased or forward biased. Now we will apply the KVL in the outer loop. Earlier we have applied the KVL in the inner loop. Now we will, after the diode is reverse biased, we will apply the KVL in the outer loop. Okay. So in this loop, plus Vi, where it is Vc minus Vc minus Vo is equal to 0. So Vo is equal to Vi minus Vc. So Vc has been charged for 100 volt. The VC has been charged for 100 volt. Okay. And when Vi is reaching to its lowest peak, the voltage is minus 120. So we will put this value here. So VO will be at Vi is equal to minus 120 minus Vc is 100. So this will come about 220 minus 220 volts. Now what we have to do is, we have two values of VO. At one is we have calculated 20 volt and another one we have calculated as minus 220 volts. This is also one of the important question. For now we will make the graph, right? We are making the graph for the VO. So we will mark one line of 20 volts. Okay. See, when this waveform, for this particular waveform, the voltage across the output is 20 volts. Okay. For this part, the voltage across the diode is 20 volts constant. We have calculated, right? Now, see, for this part, we have calculated the voltage is at minus 220. So we will find out the, the point minus 220. Let's say here it is. Minus 220 volts. Now we will make our graph. That this point has reached here, and now this will go like this. Okay, like that. Okay, so here this is not exactly the same, but this will vary like. So this graph will go up to minus 220. Now this would be the output waveform for the clamper circuit. So how you have to calculate for the forward bias and reverse bias, remake the circuit, and then the final graph. Okay, so take help of the explanations and try to be very accurate while you are giving the answers, right? Thank you.